Yeah, now you can begin.
Yeah, okay. My screen is visible, right, Parth?
Yeah, yeah, it's visible.
Okay,
So,
all right.
Rohit, could you introduce ourselves?
Yeah, sure. I'm Rohit. I'm a final year master student in EE1, and Parth is also a final
Yeah,
year MTech. Yeah, you can go on.
yeah. So I am a final year MTech RA, third year MTech RA, and my specialization branch is E3. Yeah. So Rohit will start. Yeah.
Yeah, thank you all for attending this session. We really want you to try the things out as we go on, as we go along here, and feel free to ask any questions. You can drop them in the chat box, and the one. So we'll take turns. Parth and I will take turns explaining things. So the one who's free will try to answer your questions. So we'll try to make it as interactive as possible. All right. To begin with, let's start Python somewhere. So if you're a Windows user, you can just type either Python, and you should see some Python app available. You can click on that and open Python. That's one way. Or you can go to CMD, which is the command prompt, open that, and then type Python here. That will start a Python session. That's also okay. If you're in a Linux environment, then you can just open the terminal with Control Alt T and then type Python or Python 3, and that'll start a Python session. Or if you're already in, say, Google Colab, then you don't really have to do anything. Python's already running in Google Colab. So when you type Python, what happens is it starts this interactive live Python session, which you can basically use as a platform to run code and just check things out. And in the background is Python that's running. So one of the simplest uses of Python is to use it as a calculator. So you can just add two numbers, and it will show you the sum, subtract numbers. So you can basically do all kinds of operations. And before we go on to variables, you can just try some simple things like this out. So for example, if you do 2 upon 3, it'll show you it'll do the fractional division and show you the quotient. And if you put 2 slashes, then it'll show you only the integer part of it. And you can multiply two numbers using 2 star 3. So, you must all be aware either from C or some other programming language that numbers have two types, either int or float. So for example, if I type of 2, then it shows that the class is int. That's the type of the number 2. And if I say put a dot after it, or if I write 2.0, then the type is float. So these are the basic number data types in Python. And so by default, when you perform division in Python 3, in Python 2, it's a little different, but in Python 3, when you perform division, by default, it assumes that it's a float division and not an int type division. And you have to explicitly mention if you want an integer output from the division. Okay, there's also, so apart from writing numbers like 2 in the form of integers or as float types like 2.5 and so on, you can, so somebody suggested 2 to the power 3. So the notation for power is 2 star star 3. This symbol has some other meaning. That's a bitwise operation. So if you want to do 2 to the power 3, then you have to use 2 stars, 2 star star 3. That does 2 to the power 3. There's also another notation, for example, in the scientific notation of writing numbers, where you write 1e 10, which basically denotes that it's 1 followed by 10 zeros. So you can just write that here, and Python understands what that means. So as you go on trying things out here, it can start filling up the space. So if you're on Linux, then you can type Control L, hold Control and hit L, and that will clear the screen. But if you're on Windows, that might not work, and you can just scroll down, and everything that you've already typed so far will just move up. Okay, so now let's talk about the variables and how you can assign values to these variables. All right. So variables, so the first thing you do when we talk about variables is assign the variable some name. So let's call our variable var underscore 1, and we give it a value 2. So if from C or MATLAB, you might know that you generally have to put a semicolon at the end. In MATLAB, that just suppresses the print output, but in Python, in any case, it does not print when you assign a value. So if you just type var1 equals 2, the value 2 is assigned to var underscore 1. And if you want to see the value, you can just type the name of the variable and it will show you the value. So there are some things to mention about how you can name a variable. The name of the variable, like probably in other programming languages also, cannot start with a number. So you cannot have 1 underscore var equal to 2 invalid. So it tries to use this 1 as the value 1 and not as a variable name. So you cannot have the variable name starting with a number. You also cannot have any special characters other than this underscore. For example, you can't have var -1. That will not work because minus gets interpreted as a subtraction operation. Okay, and if you're already familiar with a console and a terminal, then you'll already know that pressing the up and down arrows takes you to the previous commands that you've run, and that works even here. So you can just keep scrolling up the history of the commands that you have run so far using the up and down arrow keys. All right, moving on. So we can assign different kinds of data types to these variables. So for example, let me give this a different name. So var2 is 2.5, and to perform operations, it's just like the example with adding numbers. You just type var1 plus var2 and you have the answer, and you can also do multiplication, and all of the basic operations can be done just using these variable names. So it's no different there, nothing complicated here. Okay. Yeah, so and you can also check the type of the data type of the variable using type of var1. Var1 is 2, I think. Yeah, so it's int, and var underscore 2 is float. So another point worth mentioning about variable names, what is allowed and what is not is, so for example, you cannot have a variable name called int. You can't have a variable called int because int is a reserved keyword in Python. So every programming language has some keywords that mean something specific to the programming language. You can find these easily. You can just search for Python keywords, and it'll give you a list of words. So when you're trying to assign variables, try not to use any of these in the variable name. They can form some part of your variable name, but they must not just be just this much. That's just something to remember. Most of these are just common keywords like for, if, while, etc., and so on. Okay, moving on. We can also assign character and string type values to these variables. So from C, you might remember that there is a character data type, but in Python, it's all just string data type. So even a single character is just string. So for example, you can have, and always characters are represented with a pair of inverted commas. So you need to have closing and opening and closing inverted commas to denote that this is a character. So if you just type C, Python will think that C refers to some variable, and it'll say C is not defined because we haven't really defined any variable called C. So if you want it to mean the alphabet C, then you have to put these inverted commas, and you can print that value, but by just typing var underscore 3. You can also assign longer strings to variables. So for example, you can just have hi, hello. You can even have a space, and that's valid. And if you just type var4, then it just prints out that whole string. And you can check the type of this variable. Variable 4 is also string. Variable 3, that's also string, even though it's a single character. Now, one thing that's important in Python and that distinguishes it from some other programming languages is the idea of object-oriented programming. The term might sound complicated, but what it just means is that every entity in Python, it could be a variable, it could be a function that we see later on. Sorry, maybe not function, but variables, for example, they come associated with some functions or methods as they're called. So for example, let me just demonstrate this with an example. Say, let's consider var4, which is the string hi, hello. So there are certain methods which are associated with a string data type. So you can do a lot of different things if you're dealing with a string variable. For example, you can say you want to replace the word hello with bye. You can easily do that by saying var4 dot replace. So the way to call this function replace is just variable dot replace. And that's a property that's usually associated with objects. Because this var4 is an object which has a method called replace, you can do something like this. So you can say replace hello, comma, bye. So the first argument is what you want to replace, and the second is what you want to replace it with. Yeah, so doing this just prints out the value that this operation gives, but it doesn't actually change the value of var4. If you want to change it in var4, then you have to assign the output of that operation to back to the variable. So then if you try var4, then it's changed now. Similarly, so there are a bunch of other methods like this associated with particularly with string data types. For example, you can capitalize the first letter and so on, and you can easily find the available methods by just searching for Python string methods, and you should be able to see a list of all the methods that you can use with string variables. These might not be always important to you, but you'll start. So as you go on coding more and more in Python, at some point of time or the other, you'll want some particular kind of function, and you might find that here. All right. So along the same lines of assigning a variable back to itself, some of you might be familiar from C with this practice of writing plus equal to, which does, so let's say var1 is 2 to start with, and then we do var1 plus equal to 3. What it is equivalent to is var1 equals var1 plus 3. So the short form of writing that is just plus equal to 3, and var1 changed from 2 to 5. And this can be extrapolated to other operations also. So you can have minus equal to, or star equal to, or division equal to, so on. So all of those perform the operation and assign the value back to the original variable. Okay, apart from these mathematical operations, there are also other comparison operations. For example, you can check if two variables are equal, or if one is lesser than the other, and so on. Let's try that out. So var1 right now is 6 and var2 is 2.5. So you can just say var1 is less than var2, and what Python is going to do is it's going to check if var1 is lesser than var2, and it will tell you true or false based on whether the statement is true or not. So what we expect right now is a false for this statement because var2 is actually lesser. So Python will just output false. This is not very useful on its own, but then combined with other functions like if or especially if or while. This is useful in those cases. We'll see more examples of that later, but you can just remember that there are also these kinds of operations. And if you want to compare by checking if two values are equal, then you have to type equal to twice, because typing it once will assign the value in var2 to var1. So if you try this, it'll again say false, and greater than, then it says true. Okay, that's some basic operations that you can do with variables. So this addition and so on works well with numbers, it makes sense. But what happens if, say, we have a string and we add another string to it? So var4 is this. Let's just do var3 plus var4. And what we get is var3 appended with var4. So it just appends the character C to the beginning of var4 and just prints it out. And if you invert the order, the C gets appended at the end. But similarly, you can't do minus. Those operations do not make sense. Even star does not make sense. You can only add two strings, and what that means is to simply concatenate them. Okay. Another useful thing sometimes can be to assign multiple values to multiple, as in to assign values to multiple variables at the same time. For example, let's say we want to assign a value 2 to var1 and a value, say 5 to another variable var2. You can, one way to do that is just to do it in two different commands, but you can also write var1 comma var2 equals 2 comma 5, and you can check the value of each one, and it'll have assigned each of those in the order to the variables on the left hand side. So that's just a convenient way if you have somewhere in your script later when you start coding in Python, if you want to assign many values to many variables, if you want to assign different values to multiple variables at the same time with fewer lines of code, then this is just one way. If you want to assign the same value to multiple variables, then you can also do this. var1 equal to var2 equal to 2. In that case, both of them get assigned the same value. And so these are these build upon the ideas that we already know of simple operations, but they're just how to make things simpler to reduce the number of lines of code that you have to write. So similarly, you can have multiple comparison operations. For example, let's say 2 less than 3 less than 4. So Python, when you hit enter, Python is going to try to validate this statement. It's going to say true because the statement is true. If you invert, if you make it 2 less than 3 greater than 4, then that will be false. So you can have several such operations put together in the same line. That just makes it easier and neater, perhaps. Okay, the semicolon is not really required in Python, but using it makes no difference. So var1 equal to 2 versus var1 equal to 2 has, there's no change. It's not an error, it's no change. The only use of this semicolon operation is you can write multiple commands in the same line by separating them with semicolon. So for example, you can write these two commands which actually have nothing to do with each other. They're completely separate, but Python will execute the commands one after the other in the order that you've written if you've separated them with semicolon. So that's just another trick to keep in mind. Okay, moving on. There are also complex numbers. Python can understand complex numbers by default. You don't need any special package for that. So for example, you can write 2 plus, let's assign it to some variable, say var5 is 2 plus 3j, and let's look at var5, it's printed that way. And complex numbers come with some other useful methods. Like I mentioned, for strings, you have these methods like replace, capitalize, etc. For complex numbers, you have conjugate. So you can just type the variable name dot conjugate, and it'll print the conjugate value out. So again, remember that this hasn't changed the value in var5. It's only printing it out. If you want to change the value in var5, you have to assign the value back. Okay. So similarly, there's also real, which, sorry, yeah. So you just have to type that without the brackets, real and imag. So those print out the real and imaginary parts. These are some methods that are specific to complex numbers and are useful there. Okay, next. So these are all the basic data types in Python. Going to a slightly more useful and slightly more advanced data type. Let's talk about lists now. A list is also a data type in Python, like int, float, etc. List is a data type, and how you initialize or create a list is with the help of these square brackets. So you just go on putting the values and separate them with commas to create a list of these values. Let's try printing that out. var6 is a list of these values. So in MATLAB, you might have seen that you don't really need to use the commas, but in Python, you do need to use the commas. Okay, so but list is not limited to lists of numbers. It's a very powerful data type in Python. A list can have different kinds of data types in the same variable. So for example, in var6, I can have a character after this or a string after this all put together, and each of those values are retained as they are. So it's a really powerful data type. And as you start coding more and more in Python, you'll see that there are other more advanced data types which can also be held inside a list. So a list is a very broad, a very general data type which can be useful in lots of scenarios. But it also has some disadvantages because it's so general. For example, in MATLAB, if you had, say, lists of two numbers, and if you did one plus the other, it might give you the sum of the two. But that's not the case in Python. So let's say we have, for simplicity, let's just say we have a list of these four numbers, and let's create one more with, say, 5, 6, 7, 8. And what happens when we add these two? It actually appends them. So this is similar to the string addition operation. Python won't add the values in the lists because a list can have other data types too, right? So it doesn't make sense in those cases to try to actually sum the values. This is just something to keep in mind. And yeah, so now given this list, there is a lot of things that we can do with it, and there is a lot of things we need to know. So there's this list var6 now. How do you index the values of this list? Because it has 4 elements and the indexing starts from 0, unlike MATLAB where the indexing starts from 1. So, but it's similar to C where I think the indexing starts from 0. And you can just try out these different index values and see that it prints each value. And if you go beyond the length, then it just gives you an error saying list index out of range. So a simple way to get the length of a list is to just use this len command. So len of var6 just gives you the length, which is 4. Okay, yeah. And when indexing, you can also index a few elements together. So something like a starting element to an ending element. So we can have var6 has 4 elements. So let's say we index all the values from 2 onwards. So that's the third and fourth value because 0 and 1 are the first 2 values. So when you index it like that, the output is also a list. If you index a single value, then the data type of the output is the data type of the actual value at that position. So for example, if you did type of var6 of 2, that's just int. But if you did 2 to 4, that would be a list. So a neat thing is when if you want to index from some element all the way till the end of the list, then you don't have to type the last element of the length of the list. You can just type 2 colon and leave it at that. Python will understand that to mean from 2 all the elements till the end. Yeah, so you can just print those values and see. There are also a lot of methods and functions that are specific to lists. So you can also just search on the internet for Python list methods, and yeah, you'll see that there are a few functions that work specifically with lists. So for example, let's look at the case of this append. Let's go back to the terminal. So var6 is right now 1, 2, 3, 4, and you can say var6 dot append, open and close brackets, and within the brackets you pass an argument, which it can be a number. So if you do that, so doing this always modifies the variable in place. So if you type if you type var6 now, the list has changed and 4 has got appended at the end. Let's see if you can also append another list. Yes, you can. So, but what happens is the whole list appears as one item in var6 now. So it hasn't concatenated the list, but it has added another element, list element itself. So for example, in this case, the list now has 1, 2, 3, 4, 5, 6 elements. And if you query the last one, which is 5, then it's a whole list. So you can append even a character. That will also just get appended to var6. So append is a useful method sometimes when you're dealing with lists. If you want to say you're running a loop and you want to keep collecting values in a list in every iteration, then append is a useful function. And if you want to define an empty array, you just define empty list, then you just do it this way, var6 equal to open and close square brackets with nothing in between. Then var6 is empty. And if you want to start adding values to this, you can easily do it with append, var6 dot append, and you just say 1, var6 has that value, and you can go on appending values. Okay, that's about lists. So right now I'm just giving you a basic introduction of all these data types, but we'll actually see how these are useful in solving some other problems, or how these are actually useful in tasks that you might want to use Python for. And before I hand it over to Parth, I'd just like to mention a few things about built-in functions in Python. So you can again search for Python built-in functions, and you'll find a huge list of available functions. Those include some that we already covered, like len, that gives you the length of a list. There are also some other functions, for example, abs, which gives you the absolute value of a number. So all these functions don't work on all kinds of data types. Some are specific to certain data types. For example, this abs, it says returns the absolute value of a number. So you can't use it on, we can use it on a number, so it'll just return the absolute value, but you cannot use it on a list. So it says bad operand type. You can't use it on a list or a character. Those things don't make sense. So you really have to just find out what each function applies to, and you don't have to look at the list and memorize all of these. These will come to you as you start coding in Python and want to implement some particular functionality. You can find a list of functions available here, and if something is not available here, then you can try to write your own function to do what you want. Okay, there's one more function that I'll quickly cover, which is also quite useful, which is the print function. So when you want to print a value, but we already saw that if you want to just display a variable, you can just type the name of the variable and that gets displayed. But another way is to write print of var_1. That will also print the name of the variable. And a really nice thing about print is if you want to print multiple things, and if say they are all characters, then you can just add them here. And so which was our character variable, var3 and 4. Yeah. So in print, you can just type print var3 plus var4. Yeah, so that'll just print the whole concatenated version of those two variables. And yeah, you can also just pass your own strings. You can just say print of hi, and it'll just print hi. And here, even here, you can manually go on adding strings to print. And say you want to print in different lines, then you can add the /n. So /n is a particular type of identifier for the new line character. So let's say we type this, then those two get printed on different lines, because /n also gets printed as a new line, and you have the rest. Something you might already know from C or MATLAB is the idea of a format specifier. So for example, you can say %d. So a format specifier is important when you want to restrict the type of the output. For example, in this case, the print to follow a particular data type. So for example, let's say we write it like this. Oh, sorry, I forgot a percentage here. Yeah, sorry. So the correct syntax, let me just clear that. Yeah, would be print %d. %d means an integer data type. So after that, there's no comma. You just type another percentage symbol and the value that you want. So even if you type a float value, it will restrict the output to be an integer. Similarly, you can also have %f, which means float, and that will print the value. You can also restrict the number of decimals that get printed. So for example, you can say 2.2f, and that will restrict the number of decimals to 2, the number of digits to 2 before and after the decimal. So this is really useful when you want to put together, say something like hi. So let's say you have a variable var 7, which is my name, and you want to print something like hi, my name is, and you don't want to, so one way is to just write plus var 7, that will do the job. Otherwise, you can also just write %s, s is for string, and just type var _7, that will just print it the same way. Okay, so why print is useful is generally when you write scripts and at some intermediate steps you want to know how much the script has finished running, or maybe you want to see the output, then you can just add a print statement somewhere in between and add some statement like, okay, the value of this at this point is, and then write %d, the variable, and then the percentage variable name, and that will just print out the value while the script is running. Okay, I think that's all I have to say. Parth, you can take over and talk about scripts, writing scripts. So it's really nice to have this Python console where you can just try things out, and it's endless. You can just keep doing everything here. But the problem is you can't write multiple lines of code, or if you want to write a lot of code, then it's not really useful, because every time you type something and hit enter, Python will run it. So if you want to write a few lines of code, then you might already have used scripts in other Python in other programming languages. So the rationale is similar even here. So Parth is going to talk about how you can run Python scripts, and how to write code in a script.
Okay. Yeah. Thank you. Okay, guys. Do you have any doubt till now, or should we continue? Okay. So yeah. Okay. So this is my desktop. I use VS Code as my text editor. So yeah. So this is my script file, or so-called file, Python file here. So it is somewhere. Yeah. Where is it? Yeah. So Python tutorial, if else, it should be, where is it?
Hello, Parth. Share.
Yes.
Yeah, your voice is cracking. It's cracking in between.
Yeah. Okay. Let me check. Hello. Hello.
Yeah. But,
Is it clear and loud?
right now it's clear.
Yeah. Okay. Yeah. So this is the my terminal window. So we can write, or we can what you can get. We can run script of Python, just writing like Python 3 and what you can tutorial. What happened? Yeah. So we should go to desktop first and then write a Python 3 tutorial if else and py. Yeah. So Python runs .py files. So if you write enter, it runs hello world. So as I wrote here, print hello world. Hello world. So it prints hello world. Okay. So yeah.
Parth, you
So
can
if you want to
ask them
comment
to. You can ask them to
in
open.
Python, you sorry.
You can ask them to open a text editor and then start writing this.
Okay. 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 So this is the text editor which I used in Ubuntu. It is, I think so. I don't know its name. So just write print so called hello, welcome to IIT Bombay. Let's write welcome to IIT Bombay. Yeah. Then let's save it on desktop. Desktop. Yeah. Hello. Py. You should write .py after the file name. It will only run .py file.
Hello, Rohit.
Python only
Parth.
run
Hello,
.py
hello, Parth.
files. Yeah. So save
Hello,
it.
Parth. Yeah,
Yeah.
your voice is not
Yes.
understandable because it's cracking in between a lot. So what I think that Parth can this Rohit can continue from here and can deliver the same in the next
Okay.
class. Is Rohit, is it okay?
Yeah, that's okay. So
Okay.
do you want Parth to share the screen and do things that he's doing and me to talk, or just
Yeah,
continue?
both the things are okay. You can continue from where you would start from in
Rohit.
the next class, or Parth will keep on sharing the screen, or you can talk.
Okay, for
Okay.
now, I'll
Rohit, I
probably.
am sharing my files with you. You can continue. Yeah. Please share your what you window or screen.
Yeah, okay. Mm, okay, so let's exit this, and yeah, you can open any text editor of your choice. We might have, I think we asked you to download PyCharm or Sublime Text. You can use the default also, but then these other text editors have some smart indentation, or they point out if you have missed the bracket and things like that. So yeah, it just makes it easier to write code if you have one of these other uh, text editors. I'm using Notepad++ right now. So let's just write some simple command like print hello world, and that's enough. You don't need a semicolon, you don't need anything else. You can just go ahead and save it. You can choose where to save it, wherever you want, but make sure that you add .py to the file name at the end. So let's just say test dot test script dot py and save it. Okay, now open, if you're on Windows, just open CMD and not Python. Do not open do not directly open Python if you're in Windows, because you can't run a script when you're already inside Python. And if you're on so if you're on Windows, just open the command prompt, and if you're on Ubuntu, just keep it in the terminal and exit the Python session. So to exit a Python session, if you're in a Python session like this, you can just type exit, open and close bracket. That's also a built-in function. It will exit you from the Python session. So if you're on Ubuntu, just do that or open a new terminal. Either is okay. But you shouldn't be running a Python session to run a script.
Excuse me, sir.
Yeah.
Sir, file extension आपने क्या बताया था?
.py. Sorry. Yeah. So it's test underscore script .py. You can keep the name whatever you want, but there should be a .py at the end. All right, so we saved this in the desktop, but right now, by default, when you open command prompt, it points to just the user folder. So you might have to change directory to desktop. CD is a command which works in both Windows and Ubuntu, so you should be able to do this. And now we just say Python and then, or Python 3. If you have both Python 2 and 3, then just say Python 3 here instead of Python. And then write the name of the script, full name, including the extension, and just hit enter, and that should just. So what Python is doing is it's running the script, and then if there are any print statements or anything like that, it'll produce the output on the console. All right, so this is the basic framework for running a script. Now we can go on adding more things to our script. So for example, let's say we want, one of the first things is an if-else statement that a lot of you might already be familiar with. So the syntax for that is, let's say we want to compare two numbers. So let's create two variables with, say, two numbers, var2 equal to 45, if var1 is less than var2. So this is important. At the end of the if line, you have to add the colon. Otherwise, Python throws a syntax error. This is important in Python. And then in the next line, whatever you want to appear within the if statement has to be indented. So it can be 2 spaces, 3 spaces, or 4 spaces, how many ever. But it has to be consistent throughout the if statement. So as soon as you hit enter, it aligns with the previous line's indentation. So let's say we give 2 spaces, that's our indentation. And let's say we write print var underscore 1 is less than var underscore 2. And that's it. So we can save this again. And let's go back and oh, sorry, I made a mistake in the variable name. It should be var underscore 1. Let's save that. And so it just printed that. So you don't need an end like MATLAB. In MATLAB, you might need to put an end to end the if statement. You don't need that in Python. So, but the danger here is whatever is indented gets interpreted as being within the if statement. There's a question. Oh, that's okay. All right. So let's say we want to continue and say we have some other statement after this, print hello. Then this print hello is not part of the if statement simply because it's not indented. So that's why it can be a little dangerous when you're writing Python scripts. So only whatever is indented by the same amount gets interpreted as being within the if statement. So if you want this print hello to be within the if, then it also has to be indented, but otherwise it should not be indented. Let's try that out. So we save that and run it. So it prints var1 less than var2 and prints hello. Let's change that so that let's change the condition so that the if statement is not true. So it will not go inside the if block and it will not print this statement, but it will still print this statement because it's outside the if block. Let's save that and execute. So it only prints hello. So this indentation thing is something really important to remember when you're coding in Python. Now, the next thing that comes immediately after if is an else. So again, else should not be indented because it's not within the if. It's a separate statement after the if. So else should not be indented. But what comes within else should again be indented. Something like this. So let's save this and scroll down a little bit. Yeah, now what do we expect to happen right now? var1 is lesser, so the first condition is not satisfied, so it will go to the else block. So it printed var1 is greater than var2, which is what is in the else block. You can also have elif, which is if you have so if you want multiple conditions and then put an else at the very end, then you can have something like elif. So let's say var1 equal to var2. That's another condition that's possible. Then print var1 equal to and else print var_1 greater than var2. And you can run this and it'll still print the last one. Maybe we can try equating these two so that it'll go to the middle elif block. That'll get whatever is within the elif block gets executed. So let's save that and run it. So it prints what's inside the elif block. Okay, but that doesn't mean that you. So another idea is nested if or nested if else, which means that within an if statement you have another level of if else. You can do that. So for example, let's go to another condition. If var1 is greater than var2 and if var1 is greater than var2 plus 5, then you have to remember to give two spaces or how many ever you have given the first time again after the second if block. So let's just keep it simple for now, and that's enough. So only if this print gets executed only if this is true and this is true. So instead of writing these two if conditions separately, you can also write them together. You can combine them with a logical AND operation. So that would mean if var1 is greater than var2 and so you can write and var1 is greater than var2 plus 5. So now you don't need the second if statement. You can remove that and just directly write print. We enclose each of these conditions in a bracket. So now what happens is both of these conditions will be checked and only if both are true will it come inside. Similarly, instead of and, you can also have or, and that's the logical or operation. And okay, that's about if and else. Let's quickly go to for and while loops. So writing a for loop, you might remember from MATLAB or even C maybe. It's not exactly the same. So let's say let's say you want to count from 0 to 10, then there's a built-in function called range, where you can specify the starting value and the stop value. So right now this editor is a little smart, so it knows that it's a Python script, and it's already showing me this bit of documentation which is helpful. So it's saying start and stop and step. These are the 3 arguments that range accepts. So this is just the advantage of using some editor like this, because it can provide you such help. So if you want to go at a step of 2, starting from 0 to 10, let's try 1 first. So this range of 0, 10, 1 will produce numbers starting from 0 at a step of 1. So that's 0, 1, 2, 3, 4, and so on. But it will stop before 10. It will stop at 9. It won't go up to 10. Again, after the for statement, you need to have this colon. And again, you need to have an indentation to denote what you want executed within this for loop. So whatever is indented only gets implemented within the for loop. Whatever is not part of the for loop. So let's just type print I. That will just print the values that I takes in every iteration. This in is a keyword that is just how the syntax of Python is. So for I in range 0, 10, 1 means I will go on taking the values from 0 all the way till 9. So let's run that script. So it printed each of those values in different lines, starting from 0 all the way till 9. Now, if we want to comment out the earlier portions because those are no longer necessary, you can add a hash symbol at the start of every line. That's a single line comment. But if you want to comment multiple lines together, then you add 3 single inverted commas at the start and where you want the commenting to end. So now this whole block in yellow, hopefully you can see the color change, is commented. Now save it and let's run it again. It shouldn't print the beginning part and only the numbers. All right, so that's working. Yeah, you can adjust this step parameter to adjust how much jump you want between consecutive values in the range. Another way to write a for loop is to predefine a list. So for example, let's say var3 is a list of 23, 34, 45. And you can just say, instead of saying for I in range 0 to 10, and if you want to print the values that are in this list var3, then you can just say for I in var3. That's all. So what that means is I will start taking all the values that are present in var3 in every iteration. So let's try that out. Save it and run it. It prints each of those values. Okay, so this list again can be a character list also. So you can have strings in this list, A, B, C, D, E, F, and so on. And that also works the same way. All the values in the list just get printed one after the other in separate lines. All right, and then yeah, now you can put the for and if together and say within the for loop you want the print to happen only if some condition is met. So let's say if let's change this back to an array with a list with numbers. So let's say 1, 2, 3, 4, 5. If I is less than 3, only then print I. So right now this print I comes within the if block and within the for loop. So let's try to save that and run that. I hope you're all able to follow along. If it's too fast, you can ask me to slow down a little, but I'll keep both of these visible so that you can see both. Okay, now when we run the script, it only prints the value 1 and 2 because it only prints until I is strictly less than 3. If you also wanted to print 3, there are 2 ways. You can say I less than 4, or you can say I less than or equal to. So it's just like how you would write on a piece of paper, less than equal to, and save that and run it. It prints all the way to 3. All right, so quickly, let's also look at a for loop. So we can comment this, sorry, let's look at a while loop. Okay, where let's say we have the same list. Now, when you write a while loop, you have to specify some condition. So while some condition is true, the execution will keep happening. So let's say while I is less than 3, print var 3 of I and I plus equal to 1. So we have to initialize I to some value. So let's say we start with the value 0. And in every iteration, if I is less than 3, then I gets incremented by 1. But before that, it prints the value in the ith position of this list var 3. So I starts from 0, I is less than 3, so it comes inside the loop, it prints the value at the 0th position, which is 1. I gets incremented by 1, goes to the next iteration, I is still less than 3, so it will continue. When I reaches 3, it will stop the execution and come out of the loop. So we can quickly see that. Yeah, so it printed the first 3 values because I went from 0 all the way till 2. So the values that the loop got were 0, 1, and 2 for I, and the corresponding values in var 3 are 1, 2, and 3. So that's what got printed. Another couple of statements that are useful are the continue and break statements. So for example, let's say you want to skip an iteration. Let's say you want to skip the iteration when I is equal to 1. So let's put an if statement. If I equal to 1, then continue. What this will do is, as the loop is running, in the case when I is equal to 1, it'll come inside this if block, and continue means ignore anything that's below it and go to the next iteration of the loop. So this continue is only applicable to what's within the loop. It will only skip whatever is below it, but within the loop. So it must be indented properly. So it will only ignore this print and I plus equal to 1 statements and go to the next iteration. So it skipped. Yeah, so what happened is if when in the case when I was equal to 1, it did not even get incremented. So the loop doesn't go anywhere after it's reached 1. So it'll only print. Yeah, when I equal to 0, it prints the first value of var 3, and then it got incremented by 1. It got caught here and then continue. So it's a never-ending for loop. Yeah, we should probably end it. That was a mistake. So if you want to halt the execution of a script when it's running for some reason or other, you can type Control C, hold Control and hit C. That will stop the execution right there. Yeah. And instead of continue, if you say break, then it will just end the for loop. It will not go to the next iteration, but it will just stop the while loop or for loop. These statements continue and break can also be used inside a for loop, and they have similar actions even there. So let's save this, and in this case, it just printed the first value, and then because in the very second iteration, this condition was met, the loop just broke. Okay, so that's the basics of the for and while loops. I guess we can. Is there anything else, Parth, that I should cover, or? Parth, are you there? He's probably having some trouble with his. Okay. Was there anything else? Right. So these are the basics of the for, while, if, else, and so on. If there are any questions, we can answer those now. If anybody has any questions about what's been done so far, you can ask us. But otherwise, we can probably end the session, and we can end it with a homework, which you can all try on your own, and we can discuss it in the next session. So the homework that we wanted to give you was to write a script that prints out the first n numbers of the Fibonacci sequence. So you must write the script, and when you run the script in the console, it must just print out all the values, one below the other. Let's say the first 10 numbers of the Fibonacci sequence. You can, yeah. So for this, I can just give you, I can just walk you over the plan that you might have to follow. So you must all know how to generate Fibonacci numbers, right? You have to just add the previous two values to get the next value. But at the start, you must fix the first two values to be 0 and 1. After that, you just go on adding the previous values that will give you the next value. So you must have a loop. It could be a for or while loop, and you must have one list where you go on storing the numbers in the Fibonacci sequence. You can initialize the list with 0, 1. Yeah, so just a second. I don't understand what exactly Path is saying. Yeah, so like I was saying, you can have a list where you store the values of the Fibonacci sequence, and you can have one loop where the list is initialized with 0 and 1, and then in every iteration you go on adding a new element to the list. You can append the value to the list. You can add the previous two values, the last two values in the list, and add a new value, append a new value to the same list. And then once the loop exits, and let's say the loop can be conditioned to exit when you have generated, say, 10 numbers of the sequence. Once the for loop ends, then you can print out each value of the list. So if you want to print every value in the list, you can use another for loop and go over all the elements in the for loop and go on printing each one by one.
Okay, right.
Yeah, you had something to add?
You can give example like if something and then else something. So if I like write it down, a is equal to 0. Just
Okay.
hello.
Yeah.
So yeah, a is
I
equal to
didn't.
0.
Okay.
Yeah. Okay. Then if a is 0, if a
Mm.
is
Is
0,
yes. Okay.
right, colon, print a true or something.
If what? Then what?
Print something.
Okay. Okay.
So like then else
Okay.
then say print variable d, just not quotation mark, just write d.
D.
Yeah, just run it.
Oh, okay. Let's just comment everything.
D means this is a, so write double equal. Why
Yeah.
it is not
Maybe that works only for strings.
okay.
Sure.
So now if you change the a value of a, it will throw
Okay.
error.
Yeah. So D
So
is
now
not
you
defined.
understand.
Yeah. Yeah. So that's fine. I guess that's okay. Was
So,
there
yeah.
anything else that you wanted to cover apart from what I already covered?
No, nothing else.
Okay, so that's probably it for today's session, and you can all please try out the Fibonacci sequence homework, and we can discuss it in the next session. We can probably just show you one version of how to do it. I mean, we can show our version of how to do it, and you can compare it with yours, because we'll not be able to ask each person how they did it. And you can just try and compare it with how you've done. If you already have it working, then that's great. That's okay. So the idea is
Hello,
to
sir.
just put together. Yeah.
Sir, will you cover the float like in the DSP in the upcoming session?
Cover what? Sorry.
Floats like no, mat float.
Plotting. Yeah. That's in the.
Okay, plotting library. Yeah.
Yeah, yes. Like in the DSP we use stem plot and all.
Correct.
Okay, we will cover it.
Okay.
Yeah. So the plotting requires another library to be installed and imported. So it's not built in with Python. So we'll cover importing libraries and talk about a few important libraries that people will generally need. One of which will also be plotting. So we'll cover that in the next session.
Okay. Thank you.
Anything else?
Yeah. So we can leave now.
Yeah, I guess you can stop recording.
Yes, I am stopping the recording.
Yeah.